Hey Chem Kids, Campbell here. In our second part on the mole, we're going to talk about how moles relate to liters. So far, we've said that a mole is 6.02 times 10 to the 23rd molecules or atoms of something. It's also the molar mass in grams, so we can convert between grams and moles. But what about liters? Well, anytime I have a gas at standard temperature and pressure, that's called STP, I actually have 22.4 liters of that gas. So make sure you write down that STP is 0 degrees Celsius, so that's freezing, and 1 atmosphere of pressure. Anytime we're at those conditions, 1 mole of a gas has a volume of 22.4 liters. So when I'm at standard temperature and pressure, a mole of oxygen is 22.4 liters of oxygen, which if I put on a scale weighs 32.0 grams and contains 6.02 times 10 to the 23rd molecules. The mole is cool. Now, going back to the front page of your packet, we have the last one, the last little box for volume. And so I want you to fill in that box with 22.4. Because anytime I'm given some number of liters and I'm asked to find moles, I'm going to divide. Remember, anytime we're given something else and we're finding moles, we divide by some number. So we're going to divide by 22.4 when it's liters. And if I'm given moles, remember, if I have some number of moles, then I'm going to multiply. And if I'm asked to find volume, then I multiply by 22.4. So it doesn't even matter what gas it is. As long as we're at standard temperature and pressure, I either multiply by 22.4 if I have moles and I'm finding liters, or I divide. But make sure you're working in liters and not like milliliters. So let's see how this works. I want to know how many liters are present when I have 10 moles of hydrogen. So find your number in unit, that's 10 moles. I'm trying to find liters, so when I have moles, I multiply by 22.4. Now I set it up as a fraction, 22.4 liters per mole, just so we can see we get rid of those. But all we're doing is multiplying. You have moles, you multiply. If I'm finding liters, it's 22.4. So that's 224 liters. What about if I have 17 liters of water vapor and I want to know how many moles? Well, we're going to take our 17 liters and we're going to divide by 22.4. And I get 0.76 moles of my water vapor. All right, you try these. How many moles are in 2 liters of oxygen gas? And how many liters are in 100 moles of water vapor? Pause the video and see if you can do this. Well, for the first one, we have liters, we're finding moles. So we're going to take 2 and we're going to divide by 22.4. Did you get 892 moles of oxygen gas? I hope so. And how about how many liters are present in 100 moles? Well, I have moles, so I multiply. I want to find liters, so I multiply by 22.4, and you get 2,240 liters of water vapor. How'd you do? So if I have moles, I multiply. If I want liters, it's 22.4. If I want molecules, it's 6.02 times 10 to the 23rd. If it's mass in grams, I use molar mass. And if I have something else, then I divide by whatever the conversion factor is. There's only 3. So you just ask yourself, what do you have? What are you trying to find? Now, the cool thing about moles is they're a bridge, right? If I can calculate between molecules and moles, and if I can convert between moles and mass or moles and volume, then I could find out how many molecules I have when I weigh something in lab. Oh, so how do I do that? Well, I just kind of rearranged my little diagram here. So if I start in molecules, right, and I have to go to moles first because there's no way to go from molecules to mass, just no way. I got to go through the moles. So each of these is going to be a 2-step process. The first step is going to be to go from whatever they gave me to moles, and the second one will be to go from moles to whatever I'm trying to find. So let's try one of these. I have 10.8 grams of water, and I want to know how many molecules are present. Well, remember, we can't go right from grams to molecules or molecules to grams. We're going to have to go through the mole. So this is the process we're going to go through. The first thing we're going to do is identify what was given. So find your number and your unit. I was given 10 grams of water. Sorry, 10.8 grams of water. Then what are you trying to find? Just like the old process, look at what you're given. What are you trying to find? I'm trying to find molecules, but there is no way for me to go right from grams to molecules. I have to go through the mole. So I'm going to do a gram to mole conversion first, just like we did before. And then I'm going to go from moles to molecules. So two-step process. So the first step, convert grams to moles. So how do you do that? How do you go from grams to moles? Well, remember, you're going to have to divide because you're given some number of grams. And when you're given some other unit, you're going to moles, you divide by the conversion factor. And remember, when it's grams, it's the molar mass of water. After we've calculated our molar mass of water, we're then going to divide, right? Now, anytime you have some other unit and you're going to moles, you divide by the conversion factor, which is our molar mass. And we're going to do this on the next slide. So if you're wondering. The second thing we're going to do, now we'll have moles. So once we divide by molar mass, we're going to have some moles of water. So now I can go from moles to molecules. And remember, when you have moles, you multiply. So we're just going to multiply by 6.02 times 10 to the 23rd. See, not too bad. So let's try it. All right, first thing we got to do is go from grams to moles. So we have to calculate molar mass of water. Well, water has two hydrogens, and remember that the molar mass of hydrogen is 1, it's 1.01. There's two of them, so it's going to contribute 2 grams to my molar mass. Oxygen is 16 on the periodic table. There's only one, so that's 16. So my total molar mass of water is 18 grams per mole for my water. All right, so when I have grams and I'm going to moles, I divide. So we're going to take our 10.8 grams of water and we're going to divide by our molar mass, our conversion factor, 18 grams per mole. And when I do that, I get 0.6 moles of water. What's next? Well, now that I have moles, I can go to molecules. So I'm going to multiply by my 6.02 times 10 to the 23rd. So I'm going to take my 0.6 moles of water and I'm going to multiply by 6.02 times 10 to the 23rd because that's my number of molecules per 1 mole. So 0.6 times 6.02 times 10 to the 23rd is 3.6 times 10, times 10, that doesn't look like a 10, does it? To the 23rd molecules. So 2 steps. Identify what you have, look at what you're trying to find. You've got to go through the mole. So the first conversion is actually always going to be a division. And then the second step, right, you'll have moles then, is going to be a multiplication. Let's take a look at another one. I want to know how many liters are present in 6 grams of oxygen gas at standard temperature and pressure. Well, identify what we have. We have 6 grams. So always look for the number and the unit. So I'm starting in grams. What am I trying to find? Well, I'm trying to find liters. Remember, there's no way to go from grams to liters. I've got to go through the mole. So the first thing we're going to do is we're going to convert our grams to moles. So calculate the molar mass of oxygen. Remember, there's 2 of these here. Then, once you've done that, once you've divided by the molar mass of oxygen, you're going to convert those moles to liters. See if you can do this. Pause the video and see if you can get this done. All right, let's see how you did. Well, so in our first step, right, we're going to convert our grams to moles. So we need the molar mass of oxygen, and oxygen by itself has an atomic mass of why do I keep saying 12? That's carbon. 16 times 2, because there's 2 of them here, that's 32 grams per mole. So there is my molar mass of oxygen. So we're going to take our grams, our 6 grams of oxygen, and go from grams to moles. So we're going to divide by 32. When we do that, we get 0.1875 moles of oxygen. Keep all your decimal places until you get to the end. Second step here, right, is to convert from moles to liters. All right, let's do that. So when I have moles, we multiply. I multiply by my conversion factor to get to liters, which is my 22.4. So I'm going to take that 0.875 moles of O2, and I'm going to multiply by 22.4, and I get 4.2 liters of oxygen. How'd you do? Did you get it? All right, well, I'll see you in class.